Welcome to the lesson on Introduction to Fractions. Today we will take a look at the basics of fractions, understanding what they are, and their basic definition. So let's start off by looking at the definition of a fraction and what exactly it means. A fraction is any number that is represented by a quotient of two numbers so that a and b, those numbers are represented by a divided by b, or a over b. Like mentioned, it means a divided by b. The essential idea of a being divided by b gives us an idea of a part being part of a whole. To give you an easy illustration, imagine that you have a pizza. A pizza has a whole 8 slices, and if you have 3, it is a basic fraction. So how do we write it? How do we begin to describe how we write fractions and how we look at different types of fractions, or even how we say it? The number on top of the fraction is called the numerator. It's how much you have. The number on the bottom of this fraction, in this case 4, is the denominator, how much is possible. So imagine if you have 3 over 5, it is 3/5. 7 over 12 is 7/12. And finally, 1 over 2 can be described as 1/2. But please remember that any time a fraction can be described as one number over another. Let's go back and thinking about a pizza. A pizza has 8 slices, 8 possible parts of the whole, which would make 1. So looking at a first example, we think about a pizza with 4 slices, and you've eaten one, so you have 3 left. What essentially does it mean? We have 3 over 4. 3 slices are left out of a 4 possible. An 8-slice pizza, where we've eaten 3 and we have 5 left, as seen here colored in blue. They would be represented by a 5 over 8. 5 slices left out of a possible 8. By examining visual representations of pizza, I can decide and determine by comparing them in which quantity I have more. So taking a look at a couple fraction rules, it's very important to remember that if the numerator and the denominator are equal, then the fraction equals to 1. This is always the case regardless of what the number is going to be. In case in point, if I have 5 over 5, it equals 1. And that'll be the same whether you have 3 over 3. Visually, look, I have 5 possible slices out of a 5-slice pizza. Our next example has us again taking a look at different fractions with different numbers and deciding and comparing between their quantities. We can see here between 1/2 and 5/10 being the exact same thing. They both mean that you have half your possible quantity of the whole thing. My next example has me looking at 3/7 and being the same thing as 6 over 14, because in this case, both the numerator and the denominator have been multiplied by 2. If I take a look at a slightly more complicated example, I might think about 2/3 being less than 5/6. Well, if I take the 2 and the 3 and multiply them both by 2, I get 4/6, which is of course less than 5/6 since I will compare numerators with the same denominators. But with the other example, 4 over 5 being greater than 9 over 12, we're left wondering how possibly can we make this comparison when the numerators are different and the denominators are also different. As we further explore fractions, we'll be able to determine methods in order to compare these two types of fractions. The connection to fractions in the real world could not be stronger. Imagine the world of cooking where we combine fractions and parts, tools and hardware where we're often measuring with parts and quarters of parts, and in sports where even a baseball player can go 2 for 3, which means they hit the ball twice out of 3 possible plate appearances.